So from the past two screencasts, we learned how to convert between different units and use density as a way to as a conversion factor to convert between mass to volume or vice versa. Well, whenever we have certain units on the top or the bottom of our ratio, we can actually convert within that ratio. So we're going to go through one example in this podcast, and you'll have one question on the test that is just like this one, so make sure you pay attention. So the density of manganese, which is a metal, is 7.21 grams per centimeters cubed. What is the density expressed in kilograms per meters cubed? So first of all, we want to write our knowns just like before, and we want to write our conversion factors, play the same steps that we normally do. So our first thing we usually write down is the conversion factors, or the conversion equalities, right? So we are given grams and we want to go to kilograms, so let's look at that one first. So we have grams on top of one and kilograms on top of another. Now, if you were to look at table, I think 3.2, you would see that kilo means times 1,000, so that must be bigger. And that also means that it costs 1,000 grams to make up that 1 kilogram. Or if you wanted to look at the reverse, that would be 1 kilogram over 1,000 grams. Your other conversion that we have to look at is centimeters cubed to meters cubed. So our second conversion factor, we need to figure out how to go from meters cubed to centimeters cubed. So we have to figure out, again, that centimeters cubed to meters cubed. How are we going to figure that out? Well, we know the conversion between meters and centimeters. Meters is the bigger one, so it gets a 1. Centi means times 10 to the negative second, so we would need a lot of them. Now, this cubed portion just means that you multiply the whole quantity to the third power. Same with the bottom. So our other conversion factor would be 1 meter on the bottom to the third power. And on top, it would be 100 centimeters to the third power. All right, so now we have to figure out our knowns and our unknowns. So we know that we have 7.21 grams per centimeter cubed, and our unknown is kilograms per meter cubed. So we just have to figure out how to get from one known to the unknown. So let's figure out our plan. First of all, you have to start with what they give you. So you would go from grams per centimeters cubed to, now if you want to convert the top first, that is what we're going to do in the PowerPoint. However, this would work exactly the same if you wanted to start by converting the bottom first as well. So let's start with converting the top. So you would go from grams per centimeters cubed to kilograms per centimeter cubed. And that's exactly what we need. And then we would go from centimeters cubed to meters cubed. So centimeters cubed on top and meters cubed on the bottom. And once you cross everything out, you would end up with your kilograms and your meters cubed on the bottom. So let's see how this plays out. Let's try our conversion. So you have 7.21 grams over 1 centimeter cubed. Remember, this can be used as a ratio whenever we're working with density, and it can be used as a conversion factor. So we draw our line, and again, we're going to start by converting our grams. So if we have grams on top, we must put grams on the bottom. This does not affect our centimeters cubed value because it will cancel. So grams on the bottom, and according to our different conversion equalities, the only one that works is the one that is circled. So 1,000 grams is on the bottom, 1 kilogram is on top. Now if we were to cancel these out, we're left with kilograms on top. Well, that's part of what we need for our unknown, but we need to keep going. So next we would draw our line, and we want to get our centimeters cubed to our meters cubed. So in order to do that, let's see which equality is going to do that. Since centimeters cubed is on the bottom, centimeters cubed must end up on the top. Which one of our equalities or our conversion factors fits that? Well, first off, this one definitely doesn't because there's no centimeters cubed in there. This one is a potential factor, but centimeters is on the bottom, so that won't work. Therefore, we're left with this last one. So 100 centimeters quantity cubed over 1 meter quantity cubed. All right, so if we were to cancel out those different units, we would end up with kilograms being left over on the top and meters cubed being left on the bottom. Now all that's left to do is multiply straight across and divide by your bottom values, and you would get 7.21 times 10 to the third kilograms per meters cubed. And all of this is drawn out for you in your PowerPoint as well. And remember, this is just a method of keeping track of what units you have and trying to cancel those out to go to something new. That's all dimensional analysis is. So overall, we've learned how to use density as a conversion factor. We've learned how to convert between different units and even how to convert using ratios. So hopefully we'll be able to get a lot of practice in during class, and I'll see you tomorrow.